1.5 video is a little more function notation. This one is combinations of functions, where we could add, subtract, multiply, or divide functions. So not too difficult. We did this in Algebra 2. So the first example asks us to take f plus g. So we're going to go x squared plus 4. Plus is the operation we're doing, and we add to it the 2x minus 6. So there's only one x squared. There's only one 2x. And then these are the only two like terms. So 4 and a negative 6 is negative 2. The second one, we just have to be a little more careful because it is dealing with the subtraction. So this time when we write it out, I would do x squared. But I'm going to use minus, and I'm going to put in parentheses so that I can put all of the second function, which is 2 minus x. And then when we do this, we're going to have to distribute the negative sign. So we have x squared minus 2 plus x. Now those are the only terms we have, so it's x squared plus x minus 2 if we write it in kind of a descending format. So be very careful with the negative to put everything in parentheses so that you can distribute the negative. Multiplication would be to write the 1 over x times x over x plus 1. So in this case, when we're multiplying, we can go ahead and multiply across the top, multiply across the bottom. So you could write this as x over x times x plus 1. I'm not going to distribute that particular x because I'm looking at the top, and I know that we can go ahead now and cross off those x's, and I'm left with 1 over x plus 1. We could have done it back here at the beginning, but I did want to show you that I was multiplying this particular problem. And then the last one, we are going to write f over g. So f was going on top, and g is going on the bottom, and that's really as far as we can go. Now, they're asking us to find the domain of this particular problem, and what we're concerned about is when is 1 minus x equal to 0? So if I add x to both sides, I'm going to end up with 1 equals x. So I don't want to put 1 in the bottom because that will make a division by 0. So we would say something like any real number where x is not equal to 1. That would be the domain for this particular problem. Next is composition of functions. And what we're looking at with the composition is a little bit of notation. This open circle right here means to take your function g and put it into f. So we're going to take this function and put it into that one. So if I write it out, it's going to look like 1 over something is my function f, and what's going in there is this 2x plus 1. And so then that would be the composition, g going into f. So now down here, they want us to put negative 2 into the function. And so back in Algebra 2, we actually did some problems like this where we did negative 2 into g, and whatever we got there, we put into f. But since we have the composition right there, I can simply take my 1 over 2, put negative 2 in for x, plus 1 on the bottom. So what we end up with is 1 on top, negative 3 on the bottom, or simply the fraction that's negative 1/3. And then here they're asking me to put negative 1/2 into the problem. So this is f g of negative 1/2. So we go 1 over 2, negative 1/2 plus 1. Well, negative 1/2 of 2 is negative 1. So I end up with 1 over negative 1 plus 1. And I end up with 1 over 0. Well, that would be an undefined term. So we're just going to write undefined here. So on this next page of notes, example 3 is a DIY. So what you're going to do is find the different inputs, write down your outputs, and please pay attention that there are 3 different functions. We have f, g, and h. So you are using different functions at different times. So pause the video, go through these problems, and then I will write or I'll bring up the answers for you to look at. So pause the video now. Okay, so you can see in example 3 some of the work that we've done. We're simply taking the 4 and plugging it in here into function f, and you should get an output of negative 1. Be really careful on part B right here, because negative 3 going in, a lot of students type it into their calculator and they do negative 3 squared and they get negative 9, and then they subtract the 2 and they get negative 11. So notice we're saying it's not negative 11. The answer is 7. On C, you're going to do g of 3 first, and you get an output of 7. And then you take that and put it into f. So now you take it and put it into this function. So hopefully you got a negative 7 on that one. And then again, you go h first, so negative 2 into h, and whatever you get there, you put into g. And that should be your answer. So continue with the DIY. You're going to go ahead and look at E, F, G, and H. So please pause the video now. All right, so here are the answers for E, F, G, and H. So when you put the x plus 2 into H, it goes into the x squared position first. So it's x squared, or x plus 2 plus 1 is inside that function, and then the minus 3. So this x plus 2 only replaces the x. Then you end up with this x plus 3. If you square it, box or FOIL method, you get x squared, 6x, and 9. Then you finally subtract 3, and this is your final answer. Here you should be able to put the negative 1 in for f. Whatever you get there, you're going to put it into h. You should get an output of 100. Here the a plugs into function g, so it's basically going to replace wherever you see an x, and so you're just left with a squared minus 2. But now that a squared minus 2 has to go into f, so it replaces the x. So you have negative 2 times this quantity plus 7. If you multiply it out, 4 and 7 add up to 11. And then finally, plugging a into f gives you negative 2a plus 7. That now goes into h. So again, that replaces the x only. So you still have x plus 1 here, so it replaces the x. All of it gets squared. So inside you have to add your 7 and 1 is 8. Now you square it. And so you multiply or FOIL box method, and here's your final answer. So hopefully that went well for you on that DIY. Now we're looking at doing some of the composition notation again. So let's go ahead and underline that one in green and that one in red. And so the first composition is to do f with g of x as the input. G of x as the input. So what I'm going to write down is the g function. So I'm going to leave a blank space plus 2, and now this whole function g is going into this function. It's going right there. G into f. And so the only like terms we have, I have a negative x squared, and I have 4 and 2, which gives me 6. The next one is to do g with f as the input. So I would typically write down g as 4 minus something squared. And this time, my x plus 2 is coming over and plugging in. So I can just put x plus 2 here. Now I think you should multiply that out and you get x squared plus 4x plus 4. FOIL or box method. And then the only two like terms are the 4 and the negative. Oops, I should make sure we distribute this negative sign. So that's in parentheses. Sorry. So this is 4, and now we're going to distribute, and you have negative x squared minus 4x minus 4, taking this all the way through that quantity. So now you can see that this 4 and negative 4 go away, and my final answer is negative x squared minus 4x. What they want us to do in the last thing here is compare. Notice that these two answers for A and B, they don't necessarily have to be the same, and rarely they are not going to be the same. I'm not sure that my video was recording on that last one, so this one, what they're asking you to do is take G and plug it into F. So G is this 4 minus x squared, so it's going to go into F. And when you put it in there, you're putting it in for this x. So you can see I have 4 minus x squared plus 2. Well, I don't really need the parentheses now, so the only like terms are the 2 and the 4. And so I was saying you get negative x squared plus 6. And then we're going the other direction. F is going into G. So this x plus 2 is going to go over here and drop in for that x squared. So it replaced it right there. FOIL or box method this, you get x squared plus 4x plus 4. And then these two terms will cancel out. So that was your final answer. So continuing on to example number 5. They're giving us two different equations and simply asking us to do a composition. So one more time. That means that x is going into c. So we're going to take this function and bring it over here and put it in. So c x of t simply means that we have 48 plus the 1150, and that 40t goes right here. So now if you do 48 times 40, you should get 1,920 t plus 1150. No like terms, so that's it. So in this last example, we're going to do the same thing. We're going to go ahead and take the 2t plus 1 and bring it all the way over here, put it in there, and in there. So when we keep going, t of t is going in. So it looked like 10. This is when we put our 2t plus 1 in there, 2t plus 1. And that input is being squared. Then we have minus 20. And again, 2t plus 1 goes in there. And then it's plus 600. So I'm going to pause the video now, and I would like you to FOIL out what you need to FOIL out, distribute everything, and see what you come up with. So pause the video now. So what you can see now is that I have the 2t plus 1 put in, and when you FOIL or box method, you get this quantity, and you have to distribute the 10 through everything. Take your negative 20 to both of these, and you end up with a final answer of 40 t squared plus 590. Now we're supposed to put, for the next example, we're supposed to put 12 in there. So 40t squared plus 590. And now if I put 12 in there, go ahead and go to your calculator and type that in. So 40 with the 12 in parentheses and square your parentheses plus the 590, we get something like 6,350. Now, some of you that might be paying attention to that, what you're finding out is if you put this 12 in to this function right here, you end up with a 25, which would not fit the domain of the problem. But for this particular problem, we're just getting used to inputs and stuff, and basically what it would have been is the t, which is in hours, is more than a day, and probably the problem is wearing up. So then the last one is we're supposed to take our equation again, which is 40t squared plus 590, and we're supposed to set it equal to 1200. So if you subtract 590 on both sides, you get 40t squared is equal to, I believe it's 610. Divide by 40, this will not be a nice number. So I need to start over here. T is equal to, or t squared is equal to 610 divided by 40 is 15.25. Now square root. And we've said over and over in class that when you square root, you have to do the plus or minus, but t stands for time. So the negative does not make sense. There's no negative time here. So t would be the square root of that answer. And you're getting something that's about 3.9 hours. And that's the end of 1.5.